If at all I am ever going too fast, just let me know. My handwriting is not the best, as we saw last class, so if you can't see something or don't understand what I'm writing, just let me know. I will erase and fix or read out loud. But first, thinking back to your Algebra 1, your geometry, when you hear the word solution, what comes to mind? Answer. I don't know if you said that. Okay. Answer to a problem. Anyone have a different thought about solution? Anna? Okay, so like x equals something. Anyone else? We can say this. Solution is usually an answer to a problem. It's also what makes the equation true. So keep that in mind because we'll come back to that. There are ways to determine if values are solutions or not. And again, a lot of this will look familiar or feel familiar, and that's great. If not, that's okay. Also, we're going to go through it so that you review everything. If we were to get asked this question, is 5 a solution to this equation? How would we check that? How would we know, is 5 a solution or not? Christina, I did see your hand as well. So if we put 5 in for x, we can simplify that and see, does this work or does this not? So let's do that. Put 5 in for x. And let's start to simplify this. 13 times 5 would give us what? You guys can say that out loud. 65. And would 65 minus 7 give us 58? So we can say this is a true statement. This is a solution. If we get something that is not a true statement, 57 equals 58, then this would not be a solution. Now, this is the same exact equation for number 2, but now we have a -5, so we can probably already assume that this is not going to work, but we're going to check it anyway. We're going to do the exact same thing. Put -5 in and see what we get. So this would give us -65. And -65 minus 7 would give us I don't put my calculator up. When you press negative, make sure you're hitting the thing at the bottom, not the minus. And then for the minus, actually do minus.
72.
So is this a true statement? Does -72 equal 58? No. So this is not a solution. So this is a great way to check yourself to see, did I do this correctly? If you solve an answer or solve something and you get an answer, put it back in. If it works, you did it right. If it doesn't work, something's wrong. You forgot a negative somewhere, added incorrectly, stuff happens. Do we have any questions on that before we continue? I want you to try 3 and 4, doing the exact same thing, and then we'll come back and we'll talk about it. Number 3, was this a solution? This is a no. So what did you say? Yes or no? I didn't. No. Okay, it was no. We got like -1 equals -5 or something like that. Yeah. Anyone need to see that one? Yes. Sir.
-1 equals 3 plus 4.
Anytime you have negatives or you are putting numbers in, it's good practice to put those numbers in parentheses. And then we would use our order of operation. So multiply these first. And instead of putting a plus minus, we put minus. 3 minus 8 would give us -5. And this is not a true statement, so this would not be a solution. What about the last one? Was that a solution?
Yeah.
I heard yes and no. So let's work that out. Let's double check we're all on the same page. So if you put -34 in, you would have to divide first. So -17. As I said, I think that'd be 32. And then if we added these together, we would get -12. So this is a true statement, so this is a solution. Right. If you have the Desmos graphing calculator, not right now, but like when you're practicing at home, you could put in a whole equation. It would solve it for you. If you get the same answer, then you know you did it correctly. You could also put things in and see, does it work on Desmos? On the next page, we're just going to do a couple of these. So this is getting you back in the habit of understanding what these properties are. We use them all the time to solve, but to make sure we're actually understanding. We're going to be using these properties, which means we are adding to both sides, subtracting from both sides, multiplying to both sides, dividing to both sides, or we are distributing. So in this, we are literally just writing, what did we do? Which property did we do from one step to the next? So if we are given this, and it changes to this, what happened? What did we do? I heard it. Distributive property, yep. And then from step 2 to step 3, what do we do? Or what changed? And then we can talk about what property that is afterwards.
They added.
They added what?
And this distributed
So they distributed here. They didn't distribute here, but they did somehow move it to the other side. Did they add, subtract, multiply, divide? So if they added -10 over here, they would all be on the same side. But if we add 18 to the right, then we would get that +8. So we use our addition property of equality. I'm going to shorten that and just say A for add, POE. Property of equality is what that stands for. And then to get from here to here, what do we do? Divide to both sides. So if we divide both of these by 2, we are using our division property of equality. Before we do another, do we have any questions on that one? I know some of this seems super easy, things you've done a million times in geometry and then in algebra. It gets harder, yes, but we want to start off easy. All right, we're gonna do number 3. So from this first step to this next step, what changed or what happened?
Both sides by 2.
Something happened with that too. I remember what it said. Anna?
But,
Anytime you're dividing, we have to think of like what would be the opposite. To get rid of that 2, we would multiply both sides by 2. Those 2's would go away, which is why this became 14. So we use our multiplication property of equality. And then the other steps are going to be similar to what we did before. From step 2 to step 3, what happened or what did they use? They added the 1. And then from step 3 to step 4. They divided again. They divided both sides by 5. We get 3. Usually that's going to be your last step regardless, unless you were already dividing at this last step, then it would be multiplication. Okay. Take the next minute and see if you can do number 2. Some of you were working on that already. That's great. Write the answers up here, see if yours match or if we have any questions about them. Did everyone get these 2? Do you have a question? No. All right. Did anyone have questions on these 2? Yes. Yeah. So here, since this is adding, you're subtracting the 10 to both sides, and then multiplying the negative. Okay. I know we don't have a whole lot of time left, so some of these we'll have to finish next class. But go on to the last page. So going back to our first answer, a solution is an answer to a problem. To solve an equation is to find that solution to make the equation true. I'm going to write it really fast. Find a solution to make the equation true. And then if I asked you, what is the inverse or what is the opposite operation? How do we undo addition? Subtraction. I'm just going to draw lines and arrows. How do we undo, or what is the inverse or opposite of division? Multiplication. Anyone still need this sentence up here? Okay. These ones down here, you can probably guess what they are, but if you haven't used them a lot, you may not. How do we undo something that's squared? Square root. So if I took like 2 squared, that'd be 4. If I took the square root of 4, that'd be 2. So they undo each other. They are inverse operations. So then, of course, cube root and cube are inverse operations. Like 2 cubed is 8. That'd be 2 times 2 times 2. The cube root of 8 is 2, so they undo each other. All right. take a second and read through this, either up here or on your paper. This is like your, if you forget or what do I do first, follow this. If you have parentheses, distribute. If you don't, move on. If you have like terms, so something with the same variable or with the same exponent, combine them. If not, move on. Remember that your goal is to try to get the variable by itself. So you're moving constants to the other side or moving variables. Trying to solve. We may have time to do a couple. I have a bunch of circles. I don't know if I actually want to do all of those. So I want this to be kind of what you guys need. So look at those. Of those problems, which ones do you feel like you're not sure how to start, or you want to make sure you're on the right track, or it looks complicated? Can we do that one together? And then when you have one, raise your hand. Rebecca, number 9. I'm going to circle them for now, or square them, whatever. Christina, so your hand. 9, okay. Any others? We'll start with 9, definitely. Number 8. It is. I had like circled some already as a, we could go through these if no one has them, has other questions, but okay, we'll start at 9 and then we'll do 8. They're going to be very similar, but that's all right. 3. We may not have time to do all of these today, but that's okay. Okay, so if we were starting with number 9, first step, distribute. So we have parentheses, we can distribute. We're taking this entire number, the negative and the 5, distributing it to everything in here. Everything else we're just going to keep bringing down. Make sure you do that, because if we lose something, our answer changes. So negative 5 times 3m would give us what? Negative 1. I know it's like simple math, I'm just making sure you guys are paying attention. Negative 5 times 10. Okay. And then, do we have like terms? Things with similar variables? The 4m and the 15m, negative 15m. So we can combine those, but when we do that, we're not doing opposite things. We're doing exactly what it says. So exactly what it says is 4 minus 15, which would give us negative 11. Now, we're trying to get m by itself. So we got to get rid of that 50, we got to get rid of the 11. But we're not going to touch the 11 first. We got to get rid of the 50 first. And opposite of subtraction, we said was addition. So we're going to add 50 to both sides. We have negative 11m. These would, cancel, become 0. And this would be 176. And then to get m by itself, what would be our last step? By 11, negative 11, yep. So m would equal what? I believe that is correct. We all get negative 16? So if I wanted to double check, I could put negative 16 back into each of my m's, and if this side equaled 126, I knew I would know that that is the correct answer. Do we have any questions on that one? I'm going to stop there. I will leave the other ones that we circled, and we will go back and do those next class. You'll have some time to practice this a bit before we do the second part 2 reasons.